Hey everybody, it's Mr. Carr again. Today we're going to be looking at 7.1 day 2. Focus today is going to be writing equations given our certain characteristics. So in this scenario, I want to write an equation for and graph a parabola with a focus of 2, 1 and a vertex at negative 5, 1. Sometimes it's helpful to graph some of these parts first. So for example, if my focus is at 2, 1 is right here, my vertex is at negative 5, 2, 3, 4, 5, 1 right here. So with the focus being here and my vertex here, it's going to open sideways. So here's what I know. I know that y square, I'm going to be squaring y in this scenario. What I need to know to help my equation is I need to know the length of that for p. That is 1, 2, 3, 4, 5, 6, 7. P equals 7. Without graphing it, you can always just subtract. You notice how 1 and 1 are in the same spots. So both y's are 1, so meaning that's like it's opening sideways. So I'm just going to do this to find my p. I can take 2 minus a negative 5 here to get 7. Either way is going to help both, okay? So that means it's going to go into this format. We're going to have, let's see here, because it's going to be y minus k squared is equal to 4p times x minus h. I have h and k, and I have p now is 7. So that's going to be like, it's going to look like this. It's going to be y minus 1 squared is equal to 4. I'm going to do a little off to the side. So I'm going to do 4 times 7 to give me 28. So it equals to 28 times x plus 5. Okay. So from here, for the rest of my graphing, this one's a little bit tricky because technically if I use like strategies from before, my lattice rectum has a length of 28, meaning I would go from the focus, I would go 14 spots up. So we could go 1, 2, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, something like that. Okay. So that point up there is technically going to be, let's see here, it's going to be 2, I went 10, 11, 12, 13, 14, 15, 2, 15. Then I could do the same thing going down. I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 down here. That's 2, and that's a negative 13. So again, this creates my segment that is a length of 28 for the lattice rectum. Okay, so going on to another example, let's write an equation for and graph a parabola with a vertex 3, negative 2, and a directrix of y equals negative 1. So again, if I have the graph, I'm going to start with that. 1, 2, 3, negative 2 is my vertex. My directrix is y equals negative 1, so that is a horizontal line like this. So y equals negative 1. So based on what I see here, I know it's going to be a vertical one because the directrix and vertex is the same as the distance there is the same as the focus to the vertex. So it's going to open down. Okay. So if I know that this is a space of 1 here, I'm going to go 1 more for the focus. So I know the focus point is going to be at 3, negative 3. So the biggest thing I want from that though is the fact that p is equal to a negative 1. Okay, that's going to help me find the equation because if I take 4 times that, 4 times negative 1, that's going to give me negative 4. Now I have everything I need to write my equation out. I have my vertex h and k. I know my equation is going to look like this for a vertical one. It's going to be y minus k is equal to 4. Sorry, wrong thing. Let's come back on that one. It's going to be x minus h squared is equal to 4p times y minus k. So x minus h is going to be, in this case, it'll be x minus 3 squared equals 4 times the negative 1. So that's going to be a negative 4 times y plus 2. Okay. So again, the lattice rectum length, that's going to be the absolute value of our negative 4 there. So that just equals 4. So from my focal point right here, I'm going to make a segment that's 4 long. I'm going to go 1 to the left, 1 2 to the right. And that is my parabola. Okay. And one more example for today. Write an equation for and graph a parabola that has a focus at negative 1, 7, opens up, and contains 3, 7 as a point. So this one's a little bit tricky, but we can still start with graphing what we know. The focus is at negative 1, 7. So 1, 2, 3, 4, 5, 6, 7. Okay. It opens up and it contains the point 3, 7. 3, and then 7. So there's my 3, 7 there. And then there's my negative 1, 7. So if it contains that point, notice how it's opening up. It's going to be a graph that looks like that, roughly. Notice how I am on this horizontal line that matches up there. That means that this part of the line is on the lattice rectum. So that is a length of 4 there. Meaning I could go ahead and just graph this other side. So it's going to be 1, 2, 3, 4 over here as well. So my total length is 8. So I can think of it this way. The absolute value of 4p needs to equal to 8. Well, since I was opening up, I can just consider the positive version. So 4p equals 8, which means I divide both sides by 4 and I get p equals 2. So now, again, technically I didn't need to do that. Oh no, I do need to do that because I need to figure out where's my vertex. Forgot about that. So my vertex is going to be at the point if p is equal to 2. Here's my focus. That means I'm going to go down 2 spots for that one. So my vertex is going to be at negative 1, positive 5. Okay. So I've got everything I need. I'll just go ahead, since I got these points down. I'm going to graph it right now, since I've got those points and my vertex and everything. But for my equation, since it opens up, I'm going to start with this setup. X minus 8 squared is equal to 4p times y minus k. So here's h and k. So x minus a negative 1, so it'll be plus 1 squared, is equal to 4p, which in this case is 8. So it'll be 8 times y minus 5. Okay, and that's it for our ready equation. So again, a lot of these I have to deal with starting with some kind of graphing just to get a feel for everything, but we're just applying certain facts, like the fact that the focal length, P, is the same distance there to the vertex as it is to a directrix. So maybe I give you information about directrices versus focus, things like that. If you put a point on the graph, again, it has to do with the property that it is a straight horizontal to my focal points. So that is going to be the same distance to go from there to there. Right? So that gives me my lattice rectum length, which helps me find my equation through that. A variety of things we can do with this, just a matter of fully understanding all of our characteristics and properties. Okay, that's it for today. Take care, everyone.